Okay, back in the house with some more Cadence design patterns. If you remember the last stream, I ended off on a little bit of a fluster because I couldn't actually deploy the code. As usual, it took about 15 minutes to figure out off camera with a buddy, and it always ends up being the problem existing between the keyboard and the chair. So, just going back into what we built there, what I had before was this. With the new version of Cadence, the Flow CLI that I downloaded last time, I just had to add this network flag in the emulator, and that's allowed my code to actually deploy to the accounts that I had set up in here on the emulator. So right after the stream, everything deployed. I was able to actually go through it. I did have some errors. Most of it was just some typos or wrong field names, but I did totally forget to actually link something in here that I'd have to go back through the git commit history to actually see what it was. But yeah, so I didn't get a chance to actually demonstrate the previous example, but we can run through it now really quickly before we jump into part 2. So just going back through the code quickly, what we did was we just really focused on the capability receiver design pattern, and in creating that we really needed to use a few of the other patterns anyway. So we started with named value fields for our storage paths. We created a few interfaces for the capabilities that we need. So we have our special capability, which is the one that our admin resource will pass to our capability receiver that enables the DoSomethingCool method. We have the add capability interface, and this is what our admin borrows from the actor resource to call the add capability method on that resource and pass this special capability in. This is the unlocked capability interface. So this is the private capability that the owner of the actor resource would borrow a reference to and call this method on, which would succeed if they already had the special capability, and it would fail if they didn't. This is our admin resource, so this is using our init singleton pattern to just make sure only one is created. It's given to the deployer when the contract is deployed, and it includes the special capability that gets passed into the add capability method. And then we have our actor resource, so this one has both the add capability and unlocked capability interfaces. It includes a field that's, I think this is contract. I don't know if it should be self or contract, but we're going to leave it with contract for now and let somebody point it out if it's wrong. I'll test that out maybe later. But anyway, this is where we actually store the special capability. We give that optional, so it starts out as nil. And then when the add capability method is called by the admin and the capability is passed in, then it actually contains the capability that we're looking for. And then our DoSomethingCool method, which is a super complex method that returns a simple string. So if the capability exists, it'll do this. If it doesn't, it'll return this. And we'll see this output in one of our 2 consoles because we're using the emulator. And then down below we have a simple method, so anyone can create an actor resource. This will store like the locked or disabled version of the actor resource in their account, and that will be waiting for the special capability method to be added to it or passed to it. So down in our init method, this is what gets fired as we deploy the contract. We're going to just set our named values, so our storage paths. This allows us to pull these paths in other places, namely our transactions, to actually make use of them without having to remember what the path name was, and is one of our design patterns. Init singleton pattern, so this is what I was talking about, where we create the one instance of the admin resource and save it to the admin's account storage, or the deployer's account storage in this case. Then we just link up the special capability to a private path, and that's what allows us to grab that and put it into the add capability method on the respective actor resource. So we wrote some simple transactions just to get this party started. So what do we have here? The create actor resource. So this one is called by any user and just creates the actor resource and does similar to our init method there, saves it in their account storage, links up the add capability method to a public path so the admin can grab it, links up the unlocked capability to a private path so that only the owner of this resource can grab that capability. So it's locked to their account. This add capability transaction is what the admin calls. So this, we would pass in the actor that we want to enable, and then the admin would pull the private capability to the special capability, borrow a reference to it, and pass it, or sorry, they'd store that. So they'd get the actor resource, use the public capability from the actor resource. So they're creating a reference to the add capability public method on the actor resource. They're storing the special capability, but not actually borrowing a reference to it yet. We're checking to make sure that the special capability is actually exists and is valid. And then we are calling the add capability method on the actor resource and passing in our special capability there. Otherwise, we'll just panic and let the people know we failed. And then after everything has been done and the actor resource has been fully enabled, the owner of the actor resource should call this and see that the message that they're expecting. If it does not have the special capability, this would panic out and show our I don't have the special capability message. So sounds like a lot. It's actually pretty simple. It did turn my brain into a pretzel for a little while trying to figure it out, so it was nice to just kind of focus on the actual design pattern itself and get any noise out of the way, because there were a couple of things. I think in the last stream I'd actually added the add capability method to the admin resource and done an implementation of the add capability method in there, which I ended up just stripping out because you didn't need it, and for whatever reason I thought you did. So it's nice to go through these exercises and make sure you're actually fully grasping the tools that you're using to build with. So that's cool. I was humming and hawing a little bit over like, do I add to this example, because the whole point of doing it this way was to kind of simplify it. And it does seem like there's a lot going on here, but I don't really feel like creating like a whole new smart contract just to demonstrate like a script accessible report. I think there's actually some interesting enough values that we could use just with the amount of actor resources that have been created, and then tracking the amount of enabled actor resources. So basically creating two integer values up here and just incrementing them as you call the two methods that are responsible for them, and then just creating a simple report struct that we can call. I'm gonna add that method as a public capability to the admin resource, just to kind of further demonstrate using capabilities. We totally could just have it as a public method on the contract itself, but I mean, considering this is a little bit more pattern and best practices oriented, I think it's just best to you know, protect that extra little bit, use the capability properly, and that type of thing. So that's what we're gonna do today. It's probably gonna be pretty quick. I actually after the last example, I actually went ahead and did kind of the work up front. So if you are interested in blazing ahead or just kind of what the end result is going to be, sorry, opening the wrong tabs here. There's a new branch up here called Script Accessible Report. So this will have everything that I did push earlier, or it should. No, it doesn't. Okay, never mind, I'm lying. We'll just do it right now. Forget everything I just told you. Apparently I need to learn how to use Git. Okay, so cool. We're just gonna go on the fly. I don't even have the example to work from anymore. Living the fast life. So we're just gonna start by creating our fields. These are gonna be variable fields. We're gonna call the first one total actors, and it's gonna be an unsigned int 64. probably could just get away with using an int here. There aren't going to be that many actors, but I'm just totally in the habit of using the uint64 type wherever I'm using an integer value for kind of safety reasons, just in case there are a lot. We want reliable numeric values. So the next field we're going to put in place is going to be our enabled actors. Another uint64. So these are just going to be our fields that track the creation of the actors, and then this one will just increment as the add capability method gets called. So create new actor will increment this one, add capability will increment this one, and then we'll pull these values as the script accessible report at the end of the demo. So I think the most important thing to notice right off the bat is that these are access contracts. So you won't be able to access these from a script or even from like a transaction. You would need to be running like a contract method in order to grab these. So that's what our generate report method is going to do. It'll be able to access these values because it's built into the contract, and then it'll be able to output those values in a struct for your consumption down the road. So the next step, first I'm going to do, like, whenever I add a values up here, I usually go way down to the init method and just set those values because I don't like angry text or angry text editors. So this is going to be 0 as a uint64. So we're just going to set 0, which is an int value by default, I believe, and we're going to typecast that as a uint64. Same thing with this one. Got our to-dos out of there. That's great. Cool. So we've defined, we've set, we're moving on to the next step. Next, we're going to build our script accessible report struct. So this is, you basically have structs and resources. Resources are super special. They have to be handled in a certain way. They're the type of thing, so our admin resource is the type of thing that who owns it, how many there are is very important. So that's why we're making that a resource. This struct is more kind of like a data structure, like you kind of use them for like packing up metadata or more like simple data structures that you'd be passing around. So we're going to use pub struct report struct, and we're going to give that a couple of fields. So it's like an object, really. So we're gonna have pub let, and let is like a constant value, so it will be set once and not changed. And we'll just call this one actors. It's gonna be a uint64, so it's just gonna receive the values for total actors and enabled actors. Pub let enabled uint64, open up an init method. We're going to pass these values in. Setting the values to the arguments that we passed in. Cool. Okay, so this is like, these are cool because you can actually put like methods on them just like a normal object, so it can have its methods and properties, and they're self-contained, so you can pass these around. The big difference here is like you can make copies of a struct, whereas like the rules around a resource are much more strict. You have to actually move them, you're using the move operator, and so handling them is very difficult. These are much more flexible to kind of move around your smart contract code, but at the same time you can't store a resource in a struct. That would defeat the purpose of it. There's a very embarrassingly stupid question that I asked last year, or I felt it was stupid. And it was a pretty obvious answer, but it had to get that out there. You cannot contain a resource in a struct. My very smart programmer friend had the same question shortly after, which kind of validated me for asking it and made me feel better. But anyway, I digress. That is our simple report struct. So we're going to create a new one of these and add our integer values into there. And that's what we're eventually going to be returning back to a caller in the method that we are about to build into our admin resource. Cool, so we're going to need to create an admin public interface. So this is going to be a public interface that we can get from the admin resource. So this one will have the generate report method, and this will return our report struct. That's all we need for that. Pretty simple. So now we're going to add our admin public interface to our admin resource. It's going to yell at us and say it doesn't conform to the interface because we need to add our new method. Oh yeah, sorry, I'm using create, which is a keyword for resources and not structs. So it takes our two values, and because we're grabbing these values from the smart contract, we're going to have to use the smart contract's namespace. Because we are inside a resource, if we use self here, it would try to grab these values from the resource itself. So the first value is total actors. Second value is enabled actors. Once again, pretty simple, just packs up this data and allows us to send that back to the function caller. Okay, so here's where we actually update our values for the fields. So our total actors, or sorry, this first it'll be our enabled actors. So again, we're inside a resource here, so we're going to need to update these values using the namespace. And there's no, at least as far as I'm concerned, there's still no like shortcut incrementer value. You can't just do this. You actually have to type it out. And typecast. So this method, once it adds the capability, it increments our enabled actors value by 1. Or sorry, it does that first and then adds the capability. I'm just in the habit of doing that in case I have a return value or something here that would make this unreachable. But yeah, so that increments it. You can only do this once per resource. Otherwise it's going to get reverted here because it's checking to make sure. Oop. I should probably check it. Never mind, I'm lying. Self capability should equal nil. So resource already has. Yeah, so what I did there was just add another check to make sure this value is nil. Otherwise, the resource already has the special capability, and that just prevents us from incrementing this value over and over and over again. This would just kill the method before it has a chance to do this, so it'll make our data a little bit more reliable. Cool. That's something I didn't do on the other example, so it's good that we're going from scratch. So do something cool. We don't need to change that. We're pretty much done with the smart contract. We just really need to upgrade or increment the value here for total actors, because this is where we create new actor resources. And this one we don't really need to double check or anything like that, you're going to be able to do this once, because we actually store these in our storage paths. So you can only store one active resource there in the first place. So this can only be run once per user, and every time this gets run once, I do want to increment. So off we go. Cool. Make sure we don't have, oh yeah, we do. So we have added that admin public interface. So when we do this init singleton now, we just need to make sure that as we create and store our admin resource, that we actually link this public method up as well. So this is what the general public would be able to pull from the admin resource, which is saved at the deployer's account, and actually call this generate report method on. Just making sure I don't have to namespace that any further. I think what I'm doing here is actually naughty. I should be pulling this value from the namespace. Basically set these values here to self, but don't use self if you're going to be reading from them. Otherwise you're kind of trying to read from something that's not fully initialized. So I ran into some errors with that, and I noticed the Dapper code is free of that type of stuff. So did I add a new path? I think I might have skipped that step up top. Oh yeah, okay. Admin public path, public path. So that's our named value for our new admin path. So that's where we're pointing this, or that's where we're saving this, and then we're using the target at design patterns. Admin storage path. So now we have that public capability set up, and that's what people are going to be able to use to actually generate this report and output the data from. So we don't need to do anything else here. We haven't changed the active resource. Do something cool. I originally was going to make do something cool be the generate report method, but then no, I just wanted to separate that out, especially because it doesn't make sense to have a generate report method on the active resource. I don't think it's probably a better home on the admin resource. None of this stuff is, you know, any crazy implementation or like, it's in terms of where the methods are placed, it's not really that important, I guess, but I just wanted it to make some sense. So that's all we have to do there. Now these are script accessible reports, so we don't need to write any new transactions, but we should make a folder for scripts. And we just need to write a simple script for generate report. I'm gonna be lazy and steal my import statement from an existing file, because that's the fun way to be. And then we're just gonna pass in an account address. So we want admin address as our argument here, and that's just gonna be the address. And then we just have to do a few steps. So first we need to get the admin public account object. Yeah, trying to name things clearly, especially being a bit of an educational resource. Admin address. So get account just takes the address and returns the public account object. So that's our first step to getting the actual public capability from it. So once we have the admin account, we can get admin public, and this will be our public capability. So admin account get capability. This is a reference to the admin public interface namespace, because we need to pull that from the design patterns contract. And we have it stored at admin public. Okay. Yeah, man, I was so surprised to see the price of Doge when I woke up this morning. I was just telling a buddy how I wouldn't touch that with a 10-foot pole too. The cope is real, but I mean, there's so many good projects right now. I'm still feeling pretty peachy about life. How you doing today? So we're just cleaning things up a little bit. Like this can get pretty long here, so breaking things down onto multiple lines. We're just typecasting, so getting the capability. This is the type of capability that we want to get. This is the location of the capability. We're going to borrow a reference to it, and if we can't borrow a reference to it, we're going to panic and say could not borrow a reference to the admin public capability. That looks very angry at me right now, but I'm pretty sure it's okay. So admin public, if we have it, should be able to generate a report which returns a struct. So because it's a struct and not a resource, we just need to use the normal equal sign, no arrow here or anything like that. And then we would like, so we're gonna have to do something that looks pretty ugly here. But we are going to concatenate a bunch of values together. And maybe I'll just break this up to make it somewhat easier to digest. So total actors, and that'll be report total actor, or report.actors, sorry. String. So if you remember, we returned an integer value, but we are gonna turn that to, like, we're gonna convert that to a string, and that just cleans up what we're about to do next, which you'll see. So enabled enabled to string. Okay. So we are just going to output like a simple total kind of this out of this basically type thing. So concat. So we use this concat method, and it's available on strings. And this is how you connect strings together in Cadence. So you can write a string and then just dot concat. You can put this in brackets, I think, too. If you just, nope, maybe not. Don't do that. So you can concat to a string. You will have to put a string in here or a string value. Oops, we want enabled, because it'll be enabled out of, which will just be a slash. I'm sorry about this, but it'll make our output a lot nicer. So what's ugly here is actually going to be quite nice in the console now. Yeah, so that's all we need for generate report. So I should comment that a bit. I was going to be lazy about my commenting today because I thought I had that other branch to switch to, but it looks like I butchered that. So borrow reference to the public capability. Generate a new report. We call it by its proper name. Store or convert the integer values Two strings. Log the output from the report. Okay. So all in all, pretty simple method. Basically just the first chunk is figuring out where we're looking, and the second chunk is figuring out what we're doing. So next step, I'm going to update the actual demo script and just basically run the scripts in here. So just going back through kind of what we did last time, just in case you're either joining for the first time or can't remember. It was a week ago after all. In this step, we've already deployed our code, so we're just creating a new emulator account, naming it actor. We're running our first transaction, which is creating the actor resource and linking it up to the actor's account. I've commented this step out, but this was just to demonstrate what would happen if we tried to call DoSomethingCool without actually passing that capability in, which would fail and output the error message. We can do that. I think it's kind of important to kind of run through it. But I think we're going to add the actual generate report script here because it makes more sense to actually have this step in our demo, and it'll just output like a 0 out of 1 value for enabled actors. So we will have one created actor resource, but it won't be enabled yet. So that just looks like this. So this is custom tooling. And let me just, yeah, it's generate report. So this tooling, like when you're running scripts, if it's in your scripts file, it will find it if you match the name of the file properly. But in a lot of cases, you'll have scripts and then a subfolder and then your scripts files in there. So you'll just need to actually put your subfolder name, your path basically be on the scripts folder. So if it's in the scripts folder, it'll find it. If it's in a subfolder, put your subfolder / file name in here, and then you'll be good to go. Next, we need to pass in the account argument. So we are looking into the deployer's account in order to find this public this public capability. And then we don't need to sign it because it's a script. So there's no signer, there's no transaction fee. We just need to run it. And because it's logging, it's going to log that output to our console. It'll be in this terminal window. That'll have the actual emulator output. So we're going to do that there. Then we are going to copy pasta. And we're going to do that here, which is awesome. And then I think down here, I'd written a script that I had aptly named crash and burn. So I'm just gonna do another little copy paste and do that again. So what that script does is basically tries to access the values the wrong way off the contract. So we're, instead of actually going through this report generation step, we're gonna just try to pull these values directly off of design patterns. So by accessing design patterns.total actors and enabled actors, and we'll see what the contract says. Spoiler alert, it's gonna crash and burn. It's gonna crash and burn. Okay. So for this one, we don't actually need to look into, oops, I should probably keep that though, because I am going to not want to type all that out again. It's Friday, I'm lazy, just want to hang with you guys. Okay, so we don't need to get the admin public account object. We really only need to do this. And you're gonna see, okay, the code hasn't been deployed. That's why it's not showing me what I was gonna tell you you were gonna see, but we'll get there. So same output, we're basically just, the only difference is we're trying to go directly into this contract and grab these fields right off the contract. And if you can remember, one of the first things we did was set these to access contract, which just prevents like an outside, like code from outside from access, or code from outside the smart contract from accessing these field values. So that's kind of where the magic happens, is this is all built into the contract. The generate report method is a part of the contract. We're passing in these values like as a part of this code, so it's all accessible here, and that's how we can actually pull these values out using the script as opposed to actually running through and trying to get it from the contract directly, which makes it safer and quite nice in terms of transaction fees because scripts are free. So you can run a script without paying for it, but you do have to pay to run a transaction. It's early, we don't know how expensive that's going to be, so this could save you an arm and a leg in the road, or down the road. Nice. I just accidentally edited the wrong file, so let me just do that. That would have been awkward. Cool. That is the intended setup. So when I go run these scripts, I'm going to get the right results. That is always appreciated. Okay. I feel like you deserve this so bad if you've been watching both streams now, because we never really got to this step last time. It was just me sad. We don't need the account argument. We should double check that we took that out of there too. Yes, okay, cool. So we don't need the to do and the fancy two-tone colors there. So I'll leave this in for the demonstration. I'm gonna pull this out of the repo though, because I'm just like, I hate having failing code in my finished work. But I think it's just important to see what happens, not only like not only with the successful code, but also trying to do it the wrong way, right? So let's make sure we got everything we need in here. This will be kind of expected, but I'll also uncomment that, run it again, and we can see what happens if we try running the DoSomethingCool method without the capability receiver being enabled. So sorry, just quickly checking to make sure I don't fall on my face when we deploy again. So we're gonna throw on the emulator on verbose mode. I'll bring that up again in just a quick I don't know if you can see that actually. Let me double check. Yeah, cool. Let me just organize things better. So we'll bring that up after we run this. To use this, what we were trying to do last time, let's just hold our breath and hope it works because we're live. That's exactly what I wanted to see. It's a good day. It's a new Good Friday. Okay. Cool. Sorry, this is always disorienting at first when I'm trying to find the output in here. So let's just match some things up. This won't always be the case. It's just early in the Alchemist stream days, so we'll actually have interfaces built up for some of this stuff, and we can run like examples on live front ends or something like that instead of watching me fish through console lines. But basically what we wanted to see, the output from our generate report scripts comes out here in the emulator output, because we're using the logs. So this is what that's returning. So if you remember in this script, we went through, everything's happy, we created our actor account, we applied our create actor resource transaction. It's just giving us the argument, so that's the account number that we actually created that resource and stored it in. Next step, we ran our generate report, which is what you see here. So it's telling us that one actor resource was created, but it is not enabled. So we have one actor resource, 0 of them enabled. That's what we want to see. So we would be at this point, and this is where if we run this, we're expecting it to fail. We have not done that yet. I'll show you that next. So this is our generate report. We've already looked at that. That's great. We have now added the capability. So transaction add capability successfully applied. Again, we're passing it the actor argument. Yeah, actor argument. So we're basically saying this is the account that we want to add this capability to. We're grabbing that resource from them and popping that capability in there so that you can call the DoSomethingCool method. At this point, we're running our script that we just built again and outputting our newly enabled actor resource value. So now you can see 1 of 1, everything's working, things are happy. Now we can call DoSomethingCool, sign and propose and pay as the actor. So that's just who are we signing as. It has to be signed by the account that owns it. So now we get the, I have this special capability output that we were looking for. Still happy. And then down here we have the ugly script reverted thing, and that's just happening because we're trying to get these access contract. See, field has contract access. We're trying to access these values from outside the contract, so we can't do it. So that's really just trying to demonstrate the difference between, well, getting these values from the actual report that the report structure that we just prepared for it, and trying to access these protected values on the contract. So pretty cool. I think we can just remove that and remove that script now, because that's pretty useless and probably confusing to somebody that doesn't know what we're doing. Cool. So the only thing that we really need to run through quickly here, I think, is just what happens if we try to call this DoSomethingCool method before we pass that capability into it. So I'm just going to restart the emulator and get us a fresh flow instance. So it just kills any contract deployment stuff that we've already done to it and allows us to start from scratch. So if I run this code again, now we have this DoSomethingCool method being fired early. And because we're panicking in the contract, it's just going to revert that transaction and kind of kill our demo script, which is fine. That's really all we want to see anyway. So yeah, it's just going to give this message if everything works as expected. Okay, so we'll run make. And there we have it. We are failing because we don't have the special capability, and that's awesome, like, because that's exactly what we want. We want a protected resource, and we want to be able to restrict certain pieces of functionality until the admin or some other level of admin has given the approval and kind of done their part of what's a multi-part transaction. So super cool. I've used this in like the Athletiverse already. I wasn't really, I was having the hardest time wrapping my head around it for whatever reason, but it came in really handy in the idea of creating league resources. So not everybody is going to be able to just create a league. I don't want that. I think that's a special capability that's going to have special, like, it's going to have a very specific impact to not only the economy of the game, but like the integrity of that economy. So I definitely want to restrict who can actually do anything with that to people that have been approved by the admin. So yeah, that was a really cool use case for it. It was something where, like, I was actually excited to get to use it, and I had a hell of a time trying to figure out how to actually write it based on the core flow files and examples, because there was so much going on in there. So I hope this I hope this repository is helpful for anyone that's maybe just trying to learn these design patterns and having a little bit of trouble, or just can't really hone in on to what the specific parts of those patterns actually are that make them work. So that would be the design patterns portion of today. I think otherwise we're just gonna touch base on like the Athletiverse stuff really quickly. It's been a super light week for development on the Athletiverse. for numerous reasons, but namely, I totally hit a wall with the team NFT. Sorry, I should go into the recent code. So I've been working on, like, we finished kind of the league structure and who can do what with the league. Like, it's very basic. It's really just a matter of creating and owning them right now, and using that, like, the capability receiver pattern that we just went over. The teams are a little bit trickier because I want anyone to be able to create a team, like, at least once. And like, I want people to own more than one team. So, like, as I looked into it, teams were more and more like an NFT every time I thought about it. The one thing I really like about Cadence and Flow is, like, the ability to, like, have resources own other resources. But I'm looking at, like, all the implementation right now would, like, require you to build kind of like an inventory dictionary or whatever. So, I mean, I could wave my hands around all silly, or I could find you what I'm talking about. This. Yeah. So in the kitty resource, so let's just consider this as my team NFT. I could create like a roster, or sorry, let's back this up. This is my league, and it needs to have like this dictionary or collection of sorts of teams. So this is a custom resource. This would be like a collection of NFTs. I don't want that. I don't want to put my teams into somebody else's league resource, because the leagues are they're gonna be owned by, you know, ideally like game developers or somebody like that. They're not gonna be owned by the same people who own teams, or, you know, like that can't be guaranteed. So I would kind of prefer to be able to store just like a public capability to my team NFT in here that would create the relationship, but it would prevent me from having to actually like move the asset into another account's storage or possession, and it would also allow me to trade that team on a marketplace without severing that team's connection to its current league, right? Because if you do back up and think about like just league, team ownership, even player agency, all that type of stuff, there is some flexibility there. Just because a team changes agents or changes owners doesn't mean it's out of the league. You should be able to keep that relationship intact regardless of which account that league, or sorry, that team or player lives in. So the way it currently is set up, I can't find a way to properly do that. I need to dig into it and do some due diligence on it to make sure that I'm not begging for something that would kind of open back doors to everyone else's dApps. Basically, that would impact the integrity of the Flow blockchain negatively. So I'm doing a little digging on that, seeing if I can find a solution, and then probably going to be talking to some of the team members to see if we can figure out a way to either work around that or work it into the proposals. So that pretty much stopped me from actually doing like major development on the Athletiverse this week. It's been more like thinking about it, researching it, trying and failing a couple of different approaches at it, looking at some of my friends' kind of patterns that they've created. One of them was really close, but just doesn't support trading, which is just so fundamental. So yeah, we'll have to figure out what goes on with that. Like, I'm sure next week's going to be a better week for Athletiverse code. Other than that, just been kind of having a blast with the small community that's starting to build around the project, and helping a few other people with some questions around Flow and Cadence. So I think that's going to be it for today. It's relatively short for an Alchemist stream, but I think it was effective. We got something done. We were able to deploy it. It didn't blow up in our face. I'm still in a good mood. We're getting into the weekend on a good note. So I'll leave you here. We're definitely going to try to do this every Friday. So, you know, Friday around 2:30 PST is probably when to expect the next Hanging Code stream. And I'm hoping to have a lot more Athletiverse content for you next week. So till then, hope you have a good one. Hope you get to enjoy some sun. Take it easy.